Welcome to the class. So in the previous class, we have discussed about the definition of statistics and what is data, and after that we have discussed about types of data. After that we have discussed about the central tendencies, that is mean, median, mode we have found in ungrouped data. Now we are going to find again mean, median, mode of grouped data. So today's topics are, what we have to cover today is, first we have to cover grouped data, and after that terms related to grouped data. After that again central tendencies of grouped data, that is mean, median, mode, and at last we will be doing cumulative frequency curves. So there are two types of curves, less than cumulative and greater than cumulative frequency curve. So we will be discussing in this class. Yesterday we have discussed the definition of grouped data. So what is grouped data? The raw data we convert into groups or classes or class intervals. So whenever the whenever the observations are more, then we will convert such observations in class intervals. So for that we will be calling it grouped data. So now in this, for example, 0 to 10, 10 to 20, 20 to 30, so on. So like this we will be converting into class intervals depending upon the observations. And in this we have some related terms, that is frequency. What is frequency? The number of observations in a particular class is called as frequency. Suppose for example I am taking the observation, for example I am collecting the data in which I have got 15 number as 7 times, 15 as 7 times. So 15 it is present in between 10 to 20. So 15 I am getting 15 as 10 times. So 15 is 10 times. So for this the observation will be 10. Why? Because 15 is repeating 10 times. So the class interval 10 to 20, 15 I am taking 10 times, therefore 10 is called the frequency of class interval 10 to 20. Okay, so this is the frequency. Now coming to the point, next one, after frequency, next term which is related to group data is limits and boundaries. What are limits and boundaries? Already we have discussed, we are taking in class intervals, but in this we are having two values. One is minimum value and another one is maximum value. So such minimum and maximum values we can take these in two types. So here I have written one example, you can see here, that is I have written here as limits and boundaries. So here I have taken 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, so you can see, so this is a preceding class interval, and this is succeeding class interval. If I take these two class intervals, this is preceding and this is succeeding class interval. So the highest value or the maximum value of preceding class interval is same as the minimum value of succeeding class intervals. It means these both are same, and if I take these two class intervals, this will be preceding and this will be succeeding. Again 30, 30. So maximum value of preceding class interval is equals to minimum value of succeeding class interval. So these both are same, and again these both are same. So if maximum value of preceding class interval is same as minimum value of succeeding class interval, then this can be taken as limits. Okay, so here we are having two limits. This is called as lower limit and this is called as upper limit. Okay, minimum value is called as lower limit and maximum value is called as upper limit. So here I have written definition of limits, that is the minimum value and the maximum value of a class interval. So the minimum value and a maximum value of a class interval is called as a limit. Okay, so minimum value is called as lower limit and maximum value is called as upper limit. So from there we can write example as lower limit, that is L from first class interval. This is first class interval and this is second class interval, this is third, this is fourth class interval. So in first class interval I am having lower limit as 10 and upper limit, okay, upper limit as 20. Okay, so this is about limits. So what is limit? The minimum value and the maximum value of a class interval is called as limit. Okay, now coming to boundaries. Here you can see the difference between these two class intervals. Here preceding maximum value of preceding class interval is same as minimum value of succeeding class interval, but here it won't be like that. The maximum value of the preceding class interval, this is preceding class interval and this is succeeding class interval. Okay, the maximum value of preceding class interval is not same as minimum value of succeeding class interval. These both are not same. Here also these both are not same. These both are not same. So for this, as they both are not same, so we have to convert these things into equal ways. That is same like as limit. So here I have written the boundaries for definition, that is actual class limits of a class interval is called as a boundary. Okay, so for this what I am doing for making this as same, so here again here I will be getting two things, that is lower boundary, LB is lower boundary and UB is upper boundary. Okay, lower boundary and upper boundary. To find lower boundary and upper boundary, okay, to make a maximum value of preceding class interval and minimum value of succeeding class interval same, what we are doing, we are finding the average of these both the things. Okay, we are finding the average of these both the things. So here, so now to convert these into normal limits, so what I am doing here, I am finding the average of this both. Okay, this is maximum value of preceding class interval and minimum value of succeeding class interval. Okay, so here what I am doing, I am taking the average of this both. So here I am finding the average of this both. So 19 plus 20 divided by 2. So here I will be getting 29, that is 39, 20 plus 19, 39 divided by 2. So on dividing 39 by 2, 39 divided by 2, I will get 2 ones are 2, 1, again 9, okay, 2 nines are 18, here the remainder will be 1. I will convert this into decimal form, that is here 0, 2 5s are 10, as remainder is 0, so the answer is 19.5. So for this we can write it as, we can convert this as, here I will get 19.5, same here as 19.5. Okay, now they both are same. Again in second situation, same, we have to find the average of this both. Okay, 29 and 30. So 29 and 30, 29 plus 30 divided by 2, I will be getting 59 divided by 2. So here I am dividing 59 divided by 2. 2 2s are 4, 1 remainder, 9 here, 2 9s are 18, 1.0, 2 5s are 10. So as remainder is 0, the answer is 29.5. So this thing we have converted. So here I will get, after finding the average, I will get upper boundary as 29.5 and here I will get 29.5. After solving these also, we will be getting 39.5. Here also we will be getting 39.5. Okay, so here I will be getting 0.5. Okay, in starting, see here maximum value of preceding class interval and minimum value of succeeding class interval, these both have become same. Here also it is same, here also it is same. So like this we will be converting the boundaries into normal limits. So these are called as boundaries. So what is the formula for finding the lower boundary and upper boundary is, okay, average of preceding, maximum value of preceding class interval and minimum value of succeeding class interval. So here also I have to remove 0.5. Why? Because I have to, so see here the common difference of these both is same. See 20 minus 10, here I will get common difference as 10. 30 minus 20, 10. 40 minus 30, 10. 50 minus 40, 10. The common differences are same. After converting into boundary, here also the common differences should be same. If I take 10 here, 19.5 minus 10, I will be getting 9.5. And here if I subtract this 29.5 minus 19.5, here I will be getting 10. Here also I will be getting 10. Here also I will be getting 10. So but as in first one I am not getting same, so for this I have to remove 0.5 to make it, okay, I have to remove 0.5 to make the common difference as same. Okay, these common differences are called as class size. Okay, these common differences, that is if we are taking in limits, upper limit minus lower limit, this is called as lower boundary, this is upper boundary. Okay, lower limit, upper limit, this is lower boundary and this is upper boundary. Common differences are same. So these common differences, okay, these common differences of class intervals are called as class size. So what is class size? Class size is, okay, upper limit minus lower limit in limits, or if I am taking in boundaries, upper boundary minus lower boundary. We will be taking this formula. Why? Because we are converting boundaries into limits. So we can take this upper limit minus lower limit. So common difference between the maximum value and minimum value is called as class size. Now we are going to find the mean of grouped data. So we have, till now we have discussed the terms related to grouped data. So now we are going to find the central tendencies of a grouped data. First one is mean. How to find the mean of grouped data? So for finding the mean of grouped data, we are having three methods. Okay, first method is direct mean method. Okay, direct mean method. Second method is assumed mean method and assumed mean method. And third method is step deviation mean method. Okay, step deviation mean method. So coming to first direct mean method. And one more thing, on solving the problem by all the three formulas or any one formula we can use, but when and where we have to use formula. So for finding the mean of the group data, we have three methods. By solving the problem by any formula, we can take any formula. If you take direct mean formula or assumed mean formula or step deviation mean formula, the answer will be same. Okay, but when and where, how we have to use these formulas, I will be telling whenever we are solving the problems. Okay, so first coming to direct mean method, the formula for direct mean method is, so I have told you the denotation of mean is x bar, or we denote the mean as x bar. So x bar is equal to, this is called as summation, that is sigma fi into xi, the product of fi and xi, sigma fi into xi divided by sigma fi. So here fi is called as frequency. Till now we have discussed about frequency. What is frequency? Frequency is the observation which is related to that class interval. Okay, frequency fi, xi is a class marks, and sigma, this symbol represents summation. It means first we have to find the product of frequency and class marks, and after that we have to add that. Okay, here we have to add all the frequencies. Now what is xi? Xi is class marks. What is class marks? Class marks is the average of lower limit and upper limit, or lower boundary and upper boundary of a particular class. So whenever he'll be giving low limits, you have to take this. We have to find the average of lower limit and upper limit. If we had given in boundaries, then we have to find the average of lower boundary and upper boundary. The average of lower limit and upper limit, or the average of lower boundary and upper boundary, in general way we can say that the average of minimum value and maximum value of a particular class interval is called as class marks. So for example, I am taking the class interval as 20 to 20, 22, 30, 32, 32, 40. These are my class intervals. Okay, so I have to find the class marks. So what I said, the average of lower limit, these are limits. So this is lower limit and upper limit. This is lower limit and upper limit. Lower limit and upper limit. Okay, average, we have to find the average for finding the class marks. So average 10 plus 20 divided by 2. So 30 divided by 2, I will be getting 15. Here 20 plus 30 divided by 2, that is 50 divided by 2. So I will get 25. And for this, okay, and for this I am getting 30 plus 40 divided by 2, that is 70 divided by 2, that is equal to 35. So the average of 10 and 20 is 15, and the average of 20 and 30 is 25, and the average of 30 and 40 is 35. So these 15, 25 and 35 are called as class marks. Okay, what is class marks? Average of minimum value and maximum value. So here I have got, and the class marks will be always present in between these two values, minimum and maximum values. This is exactly in middle. See, 10 and 20. So we will get 15 in exactly in the middle of 10 and 20. Here 25 exactly in middle of 20 and 30, and 35 exactly in middle of 30 and 40. Okay. Now coming to next, that is assumed mean method. So x bar is equal to, okay, here xi is representing class marks and x bar is representing mean. Okay, from infinite values we are taking finite value. So we are representing the mean as x bar. So assumed mean method formula, x bar is equal to a plus sigma fi into di divided by sigma fi, where di, again di is called as di is equal to xi minus a, xi minus a. Here a is nothing but assumed mean, fi is frequency, di is called as a deviation, and again xi is called as class marks. So here extra thing is adding. Here I have added a. So as here the a is added, assumed mean is added. In deviation the a is removed from class marks. Okay, adding and subtracting. Here I am adding a in summation, and here I am removing a from deviation, that is from class marks, to get a deviation. Okay, so this is the formula for, okay, what is assumed mean? A is assumed mean. First what we will do, we will assume, first of all we will assume the answer previous only. Okay, A is assumed mean, so we will assume the answer previously. So A is assumed mean, Fi is frequency, Di is deviation, and Xi is class marks. The formula of deviation Di is Xi minus A. So this is separate. This is the formula. In the place of deviation we have to substitute Xi minus A. Now coming to step deviation mean. Okay, in step deviation mean I have formula as x bar is equal to A plus sigma Fi into Ui divided by sigma Fi into H. So here Ui is called as step deviation, that is Di divided by H. I am multiplying H here. So as I am multiplying H here, the same H is divided from deviation Di. So Di divided by H, where Di, I have already told you, Di, deviation is Xi minus A divided by H. Okay, so where A is assumed mean, we will assume the mean previously. Fi is frequency, Ui step deviation, Di is a deviation, and h is called as class size. Till now only have told you what is class size, the difference between class intervals. Okay, the common difference in the intervals is called as class size. It is also called as class height. Okay, so these are the three methods by which we can find the mean of grouped data. Okay, so we will be doing problems on each and every formula so that we can get easily.